So here's the last section in our linear functions chapter, and this is a little bit new, composition of functions and piecewise functions. We've already gone over how to evaluate functions, and now we're just really double evaluating functions. So if you see notation like this, I always say work it from the inside out. Work it from the inside out. Work it from the inside out. Oops, inside out. So what I mean by that is first we're going to look at g of 3. Well, g of x was x plus 2, so do you agree that g of 3 is 3 plus 2, which is 5, right? So we're going to find really f of 5. And f of x is equal to x squared, so f of 5 is 5 squared, or 25. So you're basically doing a problem, getting the answer, plugging that answer into another problem to get the final answer. If we switch it around and do g of f of 3, now we're doing f of 3 first. F of 3 is 3 squared, which is 9. Then taking the 9 and plugging it in the g function, so 9 plus 2 is 11. It's just like a two-layered problem. Try another one. G of negative 1. What's negative 1 plus 2? Negative 1 plus 2 is 1. F of 1, 1 squared, 1. Now, of course, the functions will change and the rules will change every time. We kind of started with a little bit of an easy one. F of negative 1 is negative 1 times negative 1, which is 1. And then G of 1 is equal to 1 plus 2, or 3. So double evaluating functions called composition of functions. Just changing functions again. So now g of x here is negative 5x minus 1. So g of 4 is going to be negative 5 times 4 is negative 20 minus 1 is negative 21. Then I'm going to plug negative 21 into the f function. 2 times negative 21 is 42 plus 7, negative 35. G of f of 4, if I plug in 4, do you agree I get 15? And then what happens if I plug 15 in the g function? Negative 75 minus 1, negative 76. It can get a little harder when we have letters instead of numbers. So f of g of x is just going to say f of, the rule for g of x is negative 5x minus 1. And then if I plug that in the f function, it's going to be 2 times the quantity, negative 5x minus 1 plus 7. Or negative 10x minus 2 plus 7, or negative 10x plus 5. Similarly, g of f of x is 2x plus 7. So you're going to take the 2x plus 7 and replace the x in the g function. So negative 5 times 2x plus 7 minus 1. Or negative 10x minus 35 minus 1, or negative 10x minus 36. Now sometimes on the worksheet there's one where it gives it to you in a little bit different notation, so I just want to point that out. So if I take this problem, for example, this is the same thing as f circle g of negative 1. I know that's a little bit of weird notation. I call it fog, f circle g of negative 1, or this could also be similarly written as g circle f of negative 1. On the quiz and the test I have them like this, but there's one of each of those on the homework. Last thing, piecewise functions. You haven't seen these before, but you've seen lots of graphs of functions, right? So when we graph piecewise functions, we take a piece of each function and put it together. So I give you two little mini graphs to help. So the first one is going to be f of x equals 4, coming like from this rule here. And then the next one is going to be f of x equals x from this rule here. If I graph those functions, this is the same, of course, as y equals 4, horizontal line at y equals 4, and this is the same as y equals x, which is this line here. The piecewise part comes in with this direction. X is greater than 2. So we're only going to take the piece of that line when x is bigger than 2. So that's going to start here, open circle, and go this way. All those points I just shaded in are on that line that have x values bigger than 2. So that's going to go in the final answer, like this. Similarly with this line, we take the piece of the line where the x values are less than or equal to 2. So that's going to start at the ordered pair 2, 2, and all these points have x values less than or equal to 2. So we're going to take those two pieces and put them together to our answer graph. So this is the answer, like this graph is the answer, you are done. It takes a piece of one graph and a piece of the other graph and puts it together. Composition of functions and piecewise functions.